Here I have a brand new jigsaw puzzle, which I'm going to put together for you right now. However, like a lot of jigsaw puzzles, there are spoilers all over the front of this. So before I even turn it around, I'm going to stick a giant, there we are, post-it note. Let me double that up. I don't trust that. Here we go. There it is. Right, so this is my brand new 200-piece jigsaw puzzle. And if I dump all of these, here we go, pieces out. Oh, they come in a bag. It's nice of them. All right, so let's pop that out of the way over there for now. And then get these out. Oh, another spoiler. There's instructions, I guess. There we go. Okay, right, so I'm now going to build this jigsaw puzzle, but in the edit, it's going to jump cut to when I've done the frame. Here it is. I've got 17 pieces across by 12 pieces down, all the edge pieces put together. Now, I just have to put these ones in here, which we'll do in high speed. And there it is. It turns out it's a jigsaw puzzle of the thumbnail for this video. And that is the picture that was on the box the whole time. Check it out. You may have noticed when I made the frame of this jigsaw puzzle, it was 17 pieces by 12 pieces, and 17 times 12 is 204, not the 200 which is promised on this box. And that's what the video is about. Jigsaw puzzles, they lie. They tell you one number of pieces, they give you a different number of pieces. However, this is not the only jigsaw puzzle we'll be looking at in this video. I have all of these jigsaw puzzles as well, and actually this one isn't even the most recursive puzzle in the video. That honor is going to go to this one, which we'll get to in a second. In fact, I'm going to put all of these away apart from the space one because I want to do two things simultaneously. First of all, I want to actually build this puzzle as well. So we have two, but that's going to be done by Mat 2. Mat 2 is now done, so we can get back to the mathematics of working out what's going on with this jigsaw puzzle and this one. This puzzle, which claims 200 pieces, is a grid of jigsaw pieces, which is 17 times 12, 204 pieces. They're lying. Whereas this puzzle, for all its faults, planets facing the wrong direction, and as my wife would say, that is not what the sun looks like, it's actually got an accurate number of pieces. It's a grid 10 times 15, 150 pieces. And these are made by the same manufacturer. Why are they lying for this puzzle and not lying for this puzzle? And of course, it turns out to be based on the factors of the number of pieces they want. We're about to meet a bunch of ratios, so we'll try to give them helpful names. First of all, we have the picture ratio, and these are actually exactly the same size. They're both 49 centimeters by 36 centimeters, so I can line them up there. The short length there is 36. If we come around this way here, the long side, there it is, 49 centimeters. And if you divide 49 by 36, it's about 1.36. And I'm going to give all ratios, by the way, as their value bigger than 1, just to make life straightforward. So both of these have a picture ratio of 1.36. They also have grid ratios, which is the ratio of the number of pieces across by the number of pieces up. And importantly, those numbers have to be factors of the total number of pieces, because you multiply the number of pieces this way by the number of pieces that way to get the total number. And 200 pieces, while a nice, human-friendly round number that obviously is good for advertising a jigsaw, 200 has terrible factors. So if you wanted to make an actual puzzle with 200 pieces, it could be 1 piece by 200, very, very widescreen. Could be 2 pieces by 100, could be 4 pieces by 50, could be 5 pieces by 40. None of these are good for puzzles though. 8 pieces by 25, or 10 pieces by 20. And that's the closest you're going to get to the picture ratio. So the picture is 1.36 ratio, but the best you can do with 200 is a 2 to 1. In short, 200 terrible factors in terms of their ratios. 204, however, great factors. Specifically, 17 times 12. They've got a ratio of 1.417, and that is an awful lot closer to 1.36 than anything you're going to get from 200 pieces. So they very sneakily put in an extra 4 pieces so they can have a better grid ratio closer to the original ratio. But importantly, not quite. And even here, where they could use 10 by 15, that's close, but not quite there. That's 1.5, not 1.36. So actually, there was a third hidden ratio, and it's the ratio of the pieces. And there's a bit of an optical illusion because of the bits that stick in and out. But ideally, I guess, they should be squares. They're not quite squares. These have a slightly off-square ratio to fudge the grid ratio to be exactly the same as the picture ratio. And actually, you can work out the piece ratio, as I call it. The piece ratio is just the picture ratio divided by the grid ratio, or the other way up. I do it whichever way gives me the value above 1. In this case here, the piece ratio of 1.417 divided by 1.36 is 1.04. 4% off being a square. That's good. You can see why they went up to 204. That's so close to being square. Here, however, it's off by a bit over 10%. If you work out the piece ratio, it's 1.102-ish. But I guess the lure of having the exact number of pieces means that they've gone with a piece ratio which is further away from being a square. And they could have done that here. They could have had exactly 200 pieces, gone for the 20 by 10 grid, and then just had a piece ratio to correct that. But then the pieces would have been a ratio of 1.47. So they would have been like rectangles 1.5 times as long as they are wide. And I guess they figured that's just too far from being a square. So here it was within an acceptable distortion from a square on a piece by piece basis, whereas here it was too far, so they cheated instead by changing the number of pieces and getting pretty much back to being a square. But what about all those other puzzles? This is the jigsaw. It's a jigsaw puzzle of a picture of the jigsaw puzzle, which it is. And when we saw online someone named Darren Cullen designed this, we thought we have to sell it on Massgear. However, I have not counted the pieces to check if there's actually 1,000. I'm now worried I might be complicit in false advertising if this has not actually got 1,000 pieces. But I could just open it and count them, of course. But I thought before I do that, I wonder if I can predict how many pieces there are, because we know the ratio of the picture once it's solved because it is the box. So good. So I can measure this box, work out what the picture ratio is. I know all the factors of 1,000. I can check all the possible grid ratios, and I could check the grid ratios for other numbers near 1,000 and see if I can predict which one they've actually gone for. And you know I've coded that up to happen automatically. I've written a Python bot that I've named Jig for Jigsaw Inference Gizmo. And what you see next to me here, that's just what's on my screen as I use Jig. I'm actually going to run Jig in the original version 0. We'll get to version 1 in a moment. And what you do is you put into Jig the dimensions of the picture, the number of pieces it claims to have, and Jig will show you other possible grid ratios that might match this jigsaw puzzle. So this one here, it's going to be in the ratio of, that is, let's have a look, 33 centimeters. These can be in any units. It's just a ratio by 20. I mean, strictly speaking, that's 22.8. So why not? 22.8, and it claims to have 100 pieces. Sorry, 1,000 pieces. So let's see what Jig's got to say. Okay. So the actual picture ratio is 1.4474. I've rounded all these to just 3 or 4 decimal places. It could be 1,000 pieces in a 25:40 ratio, but that would be a grid ratio of 1.6, and it would need, it would need 1.1055 piece ratio, which we've seen. I mean, this one, they were prepared to do that kind of ratio to have the exact number of pieces. So it might have done that. It could have 1,014 pieces in a 26:39 arrangement, which would only need a piece ratio of 1.03. That could be it. Oh, underneath I've put, just for interest, I've put here are the smaller options if it had fewer pieces. But I'm assuming for false advertising reasons, they're not going to have fewer pieces. But, oh, that's interesting. What do we think it's going to be? Well, this is why I wrote a new version of Jig, because this was version 0, where it just tells you what it could be. But I was like, that's a bit boring. There's no personality. I want a bot, a little bit of pizzazz to it. So I wrote the new version of Jig, which is not version 0, it's just Jig. And Jig has opinions. So if we run Jig, it's got the same thing, exactly the same information we saw a second ago. At the bottom, however, it expresses an emotion. Well, not an emotion. It says, if I had to guess, that's Jig speaking, I think it's 1,000 pieces, but fun fact, 999 would be even better. And if you're thinking, well, hang on, how on earth is Jig making that call? I had to come up with a function to tell Jig how much it likes any given solution. So I came up with like a measure of wrongness. And at this point, this is where like maths becomes art, because there's no like definitive, this is a better option because it's closer to being square, or this one. There's no like best, objectively ultimate best way of doing it. You've got to make a judgment call. I was like, well, how do I tell Jig how to feel about the different options? And so here's what I decided. First of all, I decided we're never going to be below the number of pieces promised, because people would get a bit upset. In fact, I spoke to Karen of the Karen Puzzles YouTube channel. Of course, there's a whole bunch of Jigsaw YouTube channels. Why wouldn't there be? And I asked Karen how, proper Jigsaw puzzlers, how would they feel about having fewer than 1,000 pieces?
Fewer pieces than advertised? No thank you. What a ripoff.
Turns out I'm not a fan. So we're going to stick to above the number promised, but not too far above. Here's what I did. First of all, I figured every % off being a square is a percentage of how bad the puzzle is. So if the pieces are like 10% off being a square, the puzzle is 10% worse than if it had been a perfect match. I also assume for every extra piece, it gets 0.5% worse. And I just kind of eyeballed that. That was just my number I came up with. So I actually take 1.005, so that's 0.5% off 1 being perfect, and I raise it to the power of how many extra pieces there are. So for the case of this one, that would be to the power of 4, because each additional piece accumulates an extra 0.5% wrong, and then you multiply that by the percentage wrong in terms of the ratio of the pieces. And I can actually turn that on in Jig. So in Jig here, let's clear the screen. So in Jig here, if I switch it into kind of a debug mode, it will actually give us the badness rating of all the options. And as you can see, 1,000 pieces is the positive value, so above or equal to what they promised, with the lowest badness rating. And so that's why it gave us that. So I'm going to turn that back off again. And there you go. Grit thinks it's 1,000 pieces. Let's crack it open and find out. Oh, so many pieces. So many pieces, and they're all so small. One, two, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 700. Final 100 all together. 1, 2, 3, 4, 5, 6, 7, 8, 170. 1, 93, 96, 97, 98, 99. 99? No! 999. I mean, Jig did say 999 would be even better, 27 by 37. Ah, did I miscount by one? You know what I'm going to do? I'm going to ask Karen to check.
All right, Matt, just for you, I'm going to count them. 1, 2, 3, 23, 24, 25, 26, 38, 39, 40, 11, 12, 13, 23, 24, 25. So that's 40 across by 25 down. If we do a little math, sure enough, it's 1,000 pieces.
Phew! 1,000. We're not false advertising on mass gear. Although what's worse, false advertising on mass gear, or I just can't count. Turns out, can't count. Leave your own Parker count joke below. There we are, that one done. But now we have all of these, which, that's going to take a while. Here's how we're going to do this. I'm going to put all of these into Jig now. Jig's going to make a prediction for each one. Future Matt is going to count every single one of... I'm such a jerk to Future Matt. So Future Matt will count all of these and then express opinions, because it's not just Jig who can have opinions. Future Matt can also have an opinion on how well Jig is doing. A meta opinion, if you will. Okay, Jig up first. This one is 11 inches by 14 inches, and it claims to have 500 pieces. What does Jig reckon? Jig, if it had to guess, says 500 pieces.
Hey, Future Matt here, the real hero of this channel, and I can now confirm, yes, 500 pieces in a 25 by 20 grid. Score one for Jig.
All right. Up next, we've got Monopoly. Now, Monopoly is an interesting one because it's a square. Because it's a Monopoly board. I mean, how else could you make Monopoly more tedious than you got to put the board together as a jigsaw puzzle first? Don't tell Karen I said that. Okay, so 530 by 530 millimeters, according to the back of this. And it reckons it's a 1,000 piece limited edition. You're going to solve it a limited number of times. So I was curious to know how you'd do a square. If they had to guess, oh, of course, 1,024 pieces. Nice. So maybe it's a power of 2. Let's find out.
Nope, not a power of 2. 25 by 40 to give you exactly 1,000 pieces. And to have a square that's 25 by 40, there's a piece ratio of 1.6. I mean, look at them. Ridiculous.
Okay, and up next we've got, oh, look at that, London. A 1,000 piece, wonderful London jigsaw. What size does it think that is? It hasn't told me on the back. It hasn't told me on the front. Gonna have to go look it up. Two things. First of all, battery's about to go on my laptop. Plug that in. Secondly, it says here on the Amazon listing for this, it is 70 by 50 centimeters. So it's now 70 by 50. It claims 1,000 pieces. Does it have 1,000 pieces? Jig says no. It says it's got 1,008.
And it does indeed have 1,008. 2 to Jig, 1 to Jigsaws.
All right, up next I've gone Disney. Look at that. Oh, it's another one of these. They're not going to tell me. I'll look it up again. And it's got a picture of, you know, all your favorite films are in there. Jungle Book, Aladdin. Is that Beauty and the Beast? I don't think doesn't look like her. I mean, at least that doesn't ring a bell. Okay, 1,500 pieces is 80 by 60 centimeters. 80 by 60 centimeters, 1,500 pieces. 1,505. Ooh, that's interesting. 1,505. That's in the ratio of 35 to 43. And so that's not, okay. So he reckons that is a piece ratio of 1.0853. Let's find out.
Jig was way off. There's actually 1,530 pieces, an extra 2% pieces. That's ridiculous. So it's the 45 by 30 option, which, yes, is a good piece ratio, but I had no idea that a manufacturer would put that many extra pieces in. Poor Jig.
Okay, enough of that one. Oh, gradient. Look at that. I am not solving this one. I'll count it. No way I'm solving that. Wow, how big is that? It reckons it is... Why do they never write that on the box? Oh my goodness. Looking it up. Completed puzzle, 98 by 68.6 centimeters. So I'm actually just going to copy and paste that into Jig. Don't need centimeters. There we go. Claims it's got 2,000 pieces. Does it have 2,000 pieces? 2014. Ah, controversial. So if it has got 2,000, it'll be 40 by 50 with a piece ratio that's off by 14.29%. Surely not. If it's got 214 pieces, 2 and a bit percent. That feels likely.
It wasn't. Well, it might be likely, but it's not what happened. For this puzzle, they did go with the 50 by 40 arrangement, which is pleasing, but, I mean, why be constrained by the size of an image when it's just a gradient? You can make that whatever you want. I don't understand jigsaw people.
Finally, more Disney. Oh, look at that. This one claims to be 98 by 37.5. And the reason I got this one was I thought it'd be interesting to go something that's like a really different picture ratio. This one's super widescreen. I've pasted that in here. And it's got 1,000 pieces. Classic. Is it actually 1,000? Jig says, if Jig had to guess, 1,000 pieces. This is the final one. Jig, are they correct?
Yes, they're correct. It's 20 by 50. But, you know, I say I don't understand jigsaw people. I think it's just jigsaw manufacturers. And maybe Jig would have a better hit rate if it was just the one manufacturer. I'm trying to guess what different humans in different companies have decided. And I originally thought the increased number of pieces, it would be absolute. Like, they wouldn't want too many pieces regardless of the size, but it seems that does seem to scale a bit, given they put the extra 30 in the 1,500 one. But other times they haven't. They've just gone for a weird piece ratio. So I don't know. The moral of the story is it's very hard to throw together a simple algorithm and it predicts human behavior, even if you give it a catchy name like Jig.
There you are. I'm now going to take all of these puzzles and put them on eBay for charity. I will sign the inside of all of the lids and then put all the pieces back in, and you can buy them. All the money will go to WaterAid. This one, the signed version, will be on eBay. However, if you just want a copy of this, they're on Massgear. Go to massgear.co.uk. In the US, there might be other places that have them for sale. Check it out, see what's the cheapest option for you. However, I'm going to take all 204 pieces of this puzzle and I'm going to give them for free to the first 204 orders on Massgear that want one. I'll put it up as a free item. You can add it. There's no extra money, but you have to buy something else. Just so I don't have to cover the postage. I will put these in the first 204 orders who want them. After that, all you get is the awesome product itself. That's it. Thanks to you for watching the video. Thank you to Karen for being my jigsaw puzzle expert. Thank you to Jig for offering so many opinions. I will put Jig's terrible Python code up on GitHub, and it is awful. I actually first started writing Jig back in 2018 when someone called Helen Grant tweeted that sometimes jigsaw puzzles had the wrong number of pieces. At the time I said, that is interesting, I'm on it. And I was, and then I took a break for several years, recently dusted off Jig's code, updated it a bit, and finally did this video. So there you are. Thank you very much to Helen Grant. And finally, thank you to Future Matt for doing the bulk of the work.